Hello and welcome to the How to Pass Higher Computing Science presentation. So we're going to start off with talking about the course overview, and in particular we're starting with the exam. It's a 2-hour exam and it's worth 80 marks. Computer systems is one part of it, and it's the smallest part, as you can see, covering about 10 marks out of the 80 in the exam. A second unit is web design and development, taking about 25 marks from your exam. And database design and development is the third section. Now, it's interesting, currently you only actually have to choose one. We cover both of them in higher computing science, but you only need to choose one to focus on in your exam. And the final part and the final unit is software design development, which is the largest with 45 marks out of 80. So that is your 80-mark exam. There's also an assignment in computing science. It's a practical subject. And your assignment, the students get 6 hours, and it is worth 40 marks. So overall, the course is 120 marks, and they add them up to get their result. The assignment is open book, meaning that students are able to use any notes they've created, any projects they've worked on before, or even online resources to try and help them complete tasks, but not support each other. There is a software design and development component that is mandatory and 25 marks in total, with 15% or 15 marks rather being used for implementation and the other 10 used for other parts of the software design development unit. There's also an option to complete either a database design and development task or a web design and development task like in the exam. Each of them are allocated 15 marks, in total making up your 40 marks. So I'm going to talk a little bit about each unit. Computer systems is the first one we teach, and it has 4 parts. Part number 1 is computer structures, where we talk about the physical build of the computer and the factors that might affect how it operates. We talk about data representation, and so how information is stored in theory. We talk about security risks and precautions, and we compare all the things that could affect your computer and cause trouble. And finally, we talk about the environmental impact, and this is how technology is actually helping fight the impact climate change is having. Our second unit is web design and development. The structure of this starts off with the analysis, so we talk about the requirements of a web page, something the user might want. We design what it might look like before building it, and we discuss the benefits of that. We then spend a lot of our time on implementation, so practicing these 3 languages, HTML, CSS, and JavaScript. We then go on to test our websites and talk about how to test them. And finally, we evaluate our web page to see if it's as good as we hope it to be. Now, in this unit, there are 2 key websites we develop. Number 1 is the Emoji Madness website, and that's quite prescriptive, leading students through the experience of developing a website. And the second one, the Student Cooking website, is a bigger, more challenging website to build because it requires a lot more student-led work, and they're both key to completing this unit and doing well in their assessments. So that's something I'd stress that students spend their time working seriously on. The third unit, database design and development, follows a similar structure in that you analyze what you need to develop your database. You need to know what it requires or what the user requires. You talk about, or we will talk about, the design. So what is needed to design an effective database or related tables. We talk about how to question and query them as well. And again, a large section of database design and development is implementation. So we learn some new things on how to ask questions and how to create databases with more tables than before. Finally, we need to test our databases to make sure they store data properly. And finally, we evaluate it as well to make sure that it is accurate and it is ready to do what it's supposed to do for the client. So again, between web design and databases, one of them is optional. So you choose the one that you have performed more strongly in throughout the year to focus on for your final assessment. The key software for this one is a new software in the school this year, is SQLite Studio. It's free to download at home, and I would encourage you to practice at home with that. The final and biggest unit is software design and development, and its structure is quite similar to the last two. The start is a bit different though. We start off by comparing development methodologies. So before we learned about the iterative style, this year we learn about the agile style of software development, and we compare the best way to develop a piece of software in the market. We analyze what is required to build a piece of software. We design and prepare for building the software as well. And then as you can see, the largest part is implementation, where we learn quite a lot of new coding skills here. And these are used to just create bigger, better programs that are able to handle more data and validation, and also search that data for specific information, as well as file reading, which is a big one. We then, of course, go into testing to make sure our tables, or rather, our software is working properly and doing what it's expected to do. And then again, we evaluate it to make sure that it's going to meet the client's needs. The software we use for this is Python, which again is free to download at home. And I would encourage this to be downloaded and used for practicing at home. So that's kind of the course overview. I'm going to talk a little bit about the resources required now to pass. The first and most important one, I believe, is the Google Classroom I've set up. It has all the students added. I add all of the slides I show. I add all of the tasks, all of the homeworks, notes that I might have, additional notes I might have, revision materials I've prepared. All past papers, not just by the SQA, are here and can be found and used here as well. This is the number one go-to resource for everything to do with studying and revision. So I would encourage students to definitely use this one if they want to do well. Every student has been handed out a textbook, and it has a lot of excellent questions and more details sometimes than we've gone through in the slides, and it's always good to learn a bit more. And they have questions too. All the answers to this can be found in the Google Classroom. I've uploaded the answers, so you can check your answers there. Scholar is another resource that students can use to learn and to practice. They can access it through Glow, and it's got all the information that is covered in computing science at higher, as well as progress questions and things like that, and little tests. So a really good additional resource for practicing. BBC Bitesize offer computing science questions and information. It's slightly less detailed, but their end of unit tests are a good judge to see if you know the basics of each unit, and there's a link on the screen that you can follow to get to there. I encourage students to take notes on every class actively, so not just copying from the board. I ask them to use their own words, to ask any questions or write them down, to put a lot of images in if they can as well. So definitely not just copying off the board. I stress that. I stress that a lot. That's not a good way to learn. Something we're promoting very heavily in computing science this year is the use of active recall spreadsheets. A base one can be found in the Google Classroom, of course, but an active recall spreadsheet is where students build their own questions, maybe taking from textbooks or slides, and put in their answers, and they use it as kind of like a digital flashcard, and they can use it to track their progress. So if they've got a question right, they can mark it as green. They kind of got it right, yellow. They got it totally wrong, red. And a month later, they can come back after some studying, hopefully, and go back through the questions and try to update it. So, oh, actually, this question I got right this time, so update it to green. Or this question I used to have right was green, now has become a yellow because I kind of forgot it. And that can be used to help focus on study areas. So one of these is available for students to add work to. We are using it throughout the year. I'm having it used in class, making sure they add questions so that at the end of the year they have something that will help them practice answering questions. One of the best ways to study for passing. The slides I thought I'd just mention again, they are in the Google Classroom. All of them are there and can be found there. I upload them before the classes that are using them so that they can see them whilst doing tasks in class if they want to go back and check by themselves, which I strongly encourage. They'll never remember everything first time, so whilst doing a task, if they just want to look it up in the Google Classroom themselves, the slide they need, that's fantastic and really proactive way of working. The past papers, of course, are an excellent way to study. They can be found on the SQA website. As you can see here, this year's, or rather last year's SQA exam has been recently posted, and I think it shows you all the SQA papers back to 2018 when the course changed. I also mentioned earlier that the Google Classroom also has past papers, and those ones are made by other companies and can be used for practice as well because they're kept to a good standard. I offer supported study every Monday when there's not a teacher training, that is, every Monday between 3:45 to 4:45. It is open for them to come and do, for students to come and do homework, ask questions, catch up on tasks. I really encourage students to come. Last year, 3 students attended almost every supported study out of the 4 that came constantly, and those 3 all got A's, which was absolutely fantastic. So it does help. Getting that smaller class one-on-one help sometimes can be really helpful. Homework is something we give out regularly in computing science, so I would encourage students to do it. I'm not the only one who encourages students to do it, of course, but you can find it either in the Google Classroom and on Satchel One. I try and upload it in both locations. Students have a preference over which to use, and that's fine. If you are doubting the need for homework, I have attached a link as well to the research into the importance of homework that might swing some students or some parents. And that is it for my presentation. I hope I've given you all the information you need to help you pass, or at least direct you to the location that'll help you pass. And thank you for listening.